So this is my crystal growth so far. I haven't had any yet because I only had lab on Tuesday and it takes the crystals weeks to form. But I'm hoping to have some crystal formation in the future. However, I did accidentally spill some of it, so I do have less solution, and that will be an error in the future. So there were many steps involved in actually making the alum crystals. So first, my lab partner and I dissolved the aluminum foil using potassium hydroxide. We did this because the alum has to be in solution in order to isolate the alum molecules. A solution is a homogeneous mixture of two or more substances made up of a solvent and one or more solutes. In this reaction, the acid molecules and the surrounding molecules in this reaction, the acid molecules surround the solid molecules in a solution, which causes them to dissolve to the naked eye. According to Sciencing.com's article, is the ability to dissolve metals of physical or chemical property. The aluminum dissolves because of the electron exchange between the metal and the acid. Metals have different activities, meaning it takes different amounts of energy for them to lose electrons to the other atoms. In acids, the metals trade places with hydrogen. This causes the metal atoms to dissolve because they stop being attached to the object they originally come from. Next, we use vacuum filtration to separate the impurities from the solution. So the aluminum foil had a lot of impurities just because of manufacturing, and we pour the solution through a filter which separates the impurities from the solution. The vacuum speeds up this process. According to chem.libretext.org's article, vacuum filtration. This is a good lab technique because it allows for a greater rate of filtration. The pressure gradient is what draws the liquid through the filtration paper instead of gravity. The holes in the paper are too small to let larger particles through, which we are using to separate the impurities from the aluminum foil from the rest of the solution. And then after this, we added the sulfuric acid until it formed a precipitate. Initially, this is done to get the aluminum hydroxide to form a precipitate, and then the acid works to dissolve the precipitate back into solution. At this stage, the precipitate formed was a milky white color and appeared in what looked like strands. After this, we placed the solution on a hot plate. We did this so all of the precipitate could dissolve in the solution. Increasing the temperature of a solution causes the solubility to increase because there's more thermal energy to break the bonds between solute molecules, so they can be surrounded by solvent molecules. Both the impurities in the alum are soluble at high temperatures. Then we place the solution in an ice bath after the glass was cooled down in the hot plate. We do this to cause recrystallization because the process of purification in which in which you use solubility to remove impurities from the desired product. The idea is that the impurities need to be soluble at cold temperatures, while the desired solute needs to be insoluble at cold temperatures. But the impurities are soluble at cold temperatures. This works because once you filter the solution again, all of the alum is above the filter paper, but the impurities are still soluble. So they go through the filter paper with the rest of the solution. Next, we use vacuum filtration once again to separate the alum from the solution. This is because the colder temperatures cause the alum to form a precipitate. We use vacuum filtration in order to isolate this precipitate above the filter because this was a desired product. After this, we rinse the alum with 50-50 ethanol water and stir. And then according to Jaspers from Minnesota State University, ethanol has a good dissolving ability for many organics and is soluble with water. Adding water rapidly and dramatically reduces the solubility of many organics. If most of the impurities are organic, we can assume that they quickly became soluble and were removed once the vacuum filter was turned on. We made 40 milliliters of a saturated aqueous solution with all of the dissolved crystals. So when a solution is saturated, that means there's no more solute that can dissolve in the solvent. We wanted a saturated solution so that there would be the greatest chance of the alum to form a crystal, and when it does form a crystal, it would be a much larger crystal than if it wasn't saturated because there are more alum molecules in a saturated solution than an unsaturated solution. We put it in a container to take home with us, and we use Kim wipes to slow the process of evaporation. A slower evaporation process allows for the formation of a more perfect crystal because the atoms have more time to orient themselves in solution. Fast evaporation would mean the atoms are forced to orient themselves quickly due to a lack of solution to continue to be dissolved. The Kim wipes also work to keep out dust from the surrounding air because that would make the crystal less clear and add impurities. I would approach growing crystals of table salt by creating a saturated solution at a high temperature, and I'll know it's saturated because no more salt will be able to dissolve when I add it to the solution. I would suspend a string into the container, and I would hang it off a horizontal spoon into the container as well so the crystals would have something to form around, and I would add food coloring so the crystals could be colored. And then another way that a crystal can form are geodes. They're another example of crystal growth. They have an outer wall that's more resistant to weather, and the crystals form actually inside of the rock itself, or inside of the hollow space of the rock. And then I use volcanic geodes, and those are formed when the holes in lava flows are filled with crystals such as quartz or opal that are there from groundwater. and some of the space inside the bubbles are occupied by gases that fail to escape the lava flow. The high pressures inside the rocks lead to crystallization. And then I could do a similar thing with a table salt, except with sugar. Yes, thank you.